We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills.
Guidance is internal. 12, 11, 10, 9. Ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running. We have a liftoff. Liftoff on Apollo 11.
Shadow. 4 forward, drift into the right a little. 30 seconds forward. Contact light. Okay, engine stop. Tranquility Base here. The Eagle has landed. Roger, Tranquility. We copy you on the ground. You got a bunch of guys about to turn blue. We're going to be busy for a minute.
Armstrong is on the moon. Neil Armstrong, 38-year-old American, standing on the surface of the moon. On this July 20th, 1969.
That's one small step for man. One giant leap for mankind.
This one's going to take off on us. Today we're having our competition, May the 2nd, 2 weeks. So we're going to have a lot of things going on. There'll be 2,000 kids. Lots of people in this. It's exciting, and science is exciting. Now that you guys have seen what your stuff's done this morning or did this morning, now you know how you've got to go about improving it, right? You can see what worked and what didn't. So you got 2 weeks now that you can use science and engineering to improve that. Now, with this project, a lot of times we will see how high these things will go and compare them. Because we have so many and so limited time, we're just going to guesstimate. We're going to figure out how high they go. If we were actually doing the competition, we'll take something like this, and we'll have someone stand at a base. So we'd actually use trigonometry. We're actually using science to figure out how high the thing goes. When it goes up, we would look through the little eyepiece right here and would measure the angle. And we measure the angle, then you use something called a tangent, which is it measures the base side of your angles and so forth, and it's good mathematics. It just tells you how high it goes, and it's real easy to use. They do the same thing with trees. If her dad works for Forestry Service, they do the same type of things. So we're going to use Newton's third law. We're going to, instead of pumping this up by pumps, we're going to use our air tank. I'm going to place air in there. We're going to guesstimate about 25 pounds of air. What happens is the air will go in, it locks in behind the water. And when I take the pin off, we got a safety pin here so that we don't get hurt. And I'll pull that pin out and I'll count 1, 2, 3 and point at you, and he's going to pull. Now when you pull, whoever it belongs to, you need to put your hand like this and yank this way. And the reason we're doing that, we want to keep this flat. You see that piece? Got to keep it flat so that it will take off. So, we ready? Yeah. You do these real quick. Next person can kind of get ready, and we'll get ready to go. You see the air going in there? It's a lot of pressure. It's called Newton's third law. For every action, there is an equal and opposite reaction. Okay. A little off-center. Notice you got a lot of mist in there. We're actually forming a cloud inside that thing. This we got 2 wings flying straight up. One, 2, 3. Go. Whoa. You made the game twice. You stay behind the line, but never roll down. Oh, yeah. She broke it. Yeah, she did it hard. All right. All right. Here we go. I like this one. I like that dark black coloring on it. And it's really taking a lot of air, right? What happens, all that air inside is released and that water won't let it go out. And so it pushes against the water and it does Newton's third law, which is when it pushes against something, there's equal and opposite reaction. Just like a gun sometimes, if you fire a gun, they call it kick, it hits up against your shoulder, or if you jump out of a boat, the boat goes the opposite way. Those are all Newton's third law. So, okay, go. We never know from one year to the next what the other kids are bringing in, but every year they get better. And I know from looking at what y'all got this year, several of them would have won last year, but we don't know what Paris and Boonville and County Line, all of them. Everybody looks at their things and then try to improve on them, and that's the way we do. That's a good thing. That's a good way we do science and engineering both. He's got 4 wings, and they're just kind of like triangles on here. Notice that the ones that have several wings on it go straight. And if you only have 2 wings, notice that they're going to the east a lot, aren't they? 1, 2, 3. Is that one highest yet? No? I can't see because I'm getting rained on.
That looks beautiful, It has a stark beauty all its own. It's like much of the high desert of the United States. It's different, but it's very pretty out here. Beautiful view. Isn't that something? Magnificent sight out here. Magnificent desolation. Tranquility Base, Houston. Guidance recommendation is pings, and you're cleared for takeoff. Roger, understand. We're number 1 on the runway. 7, 6, 5, engine arm ascent. Beautiful. Very smooth. Very quiet ride. Apollo 11, this is Hornet, over. Apollo 1,